Hello, I'm Dr. Dave Highmarsh and welcome to the Other 20% series. In this video, we're going to look at meta-analysis and we're going to pose this in 3 questions based around some AKT style questions. So, strength of evidence. You're looking at data available for a new research study into lifestyle medicine intervention for type 2 diabetes. Place the study types into strengths of evidence with 1 being the strongest and 6 being the weakest. Pause the video and before we hit to the answer. So from top to bottom, systematic reviews, meta-analysis, randomised control trials next, cohort, case control studies, case series, and then expert opinion editorials. So we're going to work from bottom to top just to give you a brief overview of what they actually are. So expert opinions is exactly that, someone's opinion who's normally good in their field. So I, as a GP, could give a GP expert opinion or get something published in editorial. Just because it's someone's opinion doesn't mean it's wrong. Think about rapidly evolving conditions such as COVID-19 at the beginning of outbreak that we were reliant on infectious diseases doctors, other people invested in this to look at, what could we do to try and prevent this. So moving on, looking at case series and case studies, sort of thinking about presenting rare conditions and sort of rare presentations or sort of like a small emerging research area that you've only got a very small sample size for. So with case control, we're asking people to compare with the condition those who don't, and it's retrospective. So we're asking them a bucket load of questions. What happened and when? What did you do and why? And this reason is that there is a huge amount of recall. And so obviously you've got memory degrading, different people sort of remembering things differently. And so it's got a huge amount of bias surrounding it. Next up is looking at cohort studies, so where you take a series of people who are exposed and you watch them over a long period of time. This is sometimes referred to as a longitudinal study. It's high risk of confounding because you're just looking at that group. There's no one is randomization, there are no groups, it's just studying them, what's going on. Which brings us on nicely to randomised controlled trials. This is the gold standard for research. So where you've got 2 or more groups who are, say, given an intervention versus who are not, and you try and sort of match them as well to see what's going on. Finally, if we take a whole group of randomised controlled trials, we can then compare them to see if actually there's an overall conclusion from it. So next question, looking at Forrest plots. Reviewing an article around effectiveness of physical activity promotion based in primary care, and we're reviewing the following Forrest plot. What conclusions can be from this diagram? Select 1 or more answers. We got the answers here. Now, what's your first response? If it's like me, it would be to panic. So let's talk through this very, very slowly. So ignore the answers for the time being, and let's look at the Forrest plot, see what it shows. So right at the bottom, you've got on the left side is favours control, and on the right side is favours intervention, with this 1 being what we call the no effect line. Moving up, this black triangle shows us black diamond shows us the overall conclusion. Okay, the 2 sides of the diamond, the left and the right, are the confidence intervals based on the evidence that we got presented. As it's clear from the no effect line, the overall conclusion is that it favours intervention, and you can see that it's well clear of that 1. So looking at individual studies, you can see that you've got this black box in the middle, which represents the weight or basically how many people were in that study. And then you've got the line, which represents the confidence intervals for the highest and lowest value. And you can see here that it's well clear of the no effect line. And so that is a significant study. So moving forward, you can see that the bottom 3 are well clear of that. So again, are significantly showing that they favour intervention. You can see the 4th study up is touching the line, but is still heavily on the favours intervention. With these 2 studies, so they're sort of the top 2, all you can conclude is that they suggest that they favour intervention, but it's not statistically significant. And that's a key point to raise. Looking then at the bottom 3, what we can say is that Lawton, Colt and Murray are the 3 statistically significant studies. So let's look at the top studies, and you can see here that they sort of all vaguely sort of favours the intervention, but again, as they're touching the line, we can't draw a statistical conclusion from it. So let's go through the answers again, one at a time. So no conclusions can be drawn. Well, actually, we've gone through this. We probably can draw some conclusions. All the studies favour control. Nope. All of the studies favour intervention. Again, no. The overall study conclusion favours intervention. Now, this is asking what the black diamond is doing. And guess what? It does. 3 of the studies favour intervention. We've looked at those already and we're like, yes, it's the bottom 3. They do favour intervention. So that one's right. And 5 of the studies is wrong. So one of the studies favour control, but it's not statistically significant. Quite a different spin on things. So let's look at the top study, and actually that favours control because it's on the left-hand side, but it's not statistically significant because it's touching that no effect line. So that's correct as well. And Lawton 2008 is the highest powered study, and we can have a look at Lawton's study. We'll have a look at it, and we'll notice 2 things. One, it's the biggest black box, so we think it might be, and also the number to the right hand side, the 16.7, is the largest, so it is the highest powered study. Finally, let's look at this question, publication bias. The same study has plotted all of the publications in the diagram. From the information provided, what's the correct answer? Select one answer only. This is a funnel plot, shows no evidence of publication bias. This is a funnel plot, shows publication bias. This correlation plot shows no evidence of publication bias. This is a correlation plot, shows evidence of publication bias. So really here is asking you 2 questions. 1, what is it? And 2, is it showing any bias? Okay, so pause the video to suss out. So hopefully you got that this is a funnel plot, and as it's symmetrical and looks vaguely like a triangle, there is no evidence of publication bias, so it's the top answer. I'm going to give you a better example of this because what you're looking for is symmetry to show that there has been a range of studies published. The top diagram here shows evidence of publication bias because they're all shifted over to one side, whereas the one at the bottom is more evenly distributed, and that's really what you're looking out for. So we've rattled through meta-analysis through 3 questions, looking at strength of evidence, Forrest plots, publication biases. If you're struggling with some of these concepts, I've got 2 really supportive videos, confidence intervals, mean median mode, which I'll leave links to below. Very best luck for your AKT.